Hi mathematicians! In this video we are going to put together some concepts that you already know and kind of mix it up with some new content. But for the most part we're not talking about anything you don't already know how to do. We're just giving things some different names. The first thing you might recall from 6th and 7th grade is that a rate is when you're comparing two different quantities. So some of the most common ones you might hear is I'm driving 30 miles per hour, or I am running 20 feet per second, or something like that. And a rate is a special type of ratio. So that's probably a word that you remember from earlier in your previous years also, that a ratio is just comparing two values. So a rate of change is a ratio that compares how your y value is changing and compares that to how your x value is changing. And we're going to talk about two specific types of rates of change. The first part is a constant, and it means exactly what you think it might mean. It means that it's going to stay the same. And in our last unit, we talked about if you graph a relationship in a graph that has a constant rate of change, it's going to make a straight line, which is also known as linear. So we also have another rate of change type, which is called the variable rate of change. And it's not like talking about an algebraic variable, okay? We're talking about the fact that it varies, right? Like doesn't stay the same. That's actually why they call variables when we're talking about them in algebra, is because sometimes x is equal to 2, sometimes x is equal to 5, but it's not consistently the same, which is actually why it's called a variable. So when we're talking about a rate of change here, we're talking about a rate of change that is not the same. And if we were to graph that, it is not linear. But we will get to that just a little bit later about graphing. For now, we are going to focus on finding the rate of change from a table. And in this situation, in our notes, we are talking about Eve, who is apparently mowing some lawns to earn some money. And we need to talk about the two different quantities that are being measured here in order to determine whether or not this is a constant rate of change. So the first thing we need to know is, what is the input? What is your independent variable? Remember, we call input several different things. First of all, we use the x variable to measure it, and we also call it the independent variable. So we know from previous units that the independent variable is the one that actually has an impact on the dependent variable. And in this case, the amount of money that she earns is going to depend on how many lawns she mows, right? So this is your dependent variable, and your number of lawns is the independent variable. So in order to find the rate of change, you can see that it tells you in step 1 here that we need to find each independent rate of change between each day. So first, let's do between day 1 and day 2. And you don't necessarily have to show this the exact same way that I'm showing it. I usually, when I have a table that's horizontal like this, I just kind of make an arrow because it's telling us, or it's asking us, I should say, to find the rate of change between day 1 and day 2. So how much did her number of lawns change from day 1 to day 2? Well, it increased by 2, right? So since it's an increase, that means that that is going to be a change of 2. And then if I look at how her amount of money changed from day 1 to day 2, you can measure that in the table right here. And you can see that that changed by 30 and it increased by 30. So that is a positive 30. So a rate we know is a comparison of the two numbers in the form of a ratio. I'm getting ready to do something wrong, so don't write this down. Friends that are used to working with me in class know that if I write it in red, it means that it is wrong. So you would think that what you might do is make a ratio of 2 over 30 and then simplify it to 1 over 15. And you would probably think that because the 2 is on the top of the table and the 30 is on the bottom of the table. So that would make perfect sense. However, that is actually not how you do rate of change. So if you look over here to the side where the steps are listed, you'll see that it actually says that you're changing your output goes on top and then in the numerator, and then you're changing your input actually goes in the denominator. The reason for this is it's called a mathematical convention that, the mathematicians and scientists who do this kind of work decided to be consistent, what order are we going to put it in? And typically you're more worried about the dependent variable, right? Like, what's the point of her doing this lawn mowing in the first place? It's because she wants to earn money. So the money that she earns is the most important factor here, which is why it's going to go on the top in the numerator. So it's actually going to be 30 over 2. And I'm going to simplify this by dividing both of them by 2 so that I get 15 over 1. Here's a little bit of a blast from the past in case you don't remember this word that I just wanted to mention here really quickly. Remember the word for a rate when you have a 1 in the denominator? That is called a unit rate. Just FYI, I wanted to make sure you remember that. And then, of course, that rate of change fully simplifies because 15 over 1 is 15. Sometimes you want to leave it as the ratio, and sometimes you want to simplify it all the way to a whole number. It really kind of depends on the context of the question. So you should get used to seeing it both ways. So then the rate of change from day 2 to day 3, which we're asked to do next, you can see that the increase of the money was 45. So it's going to be 45 over 3. So you might be tempted to think that it's not a constant rate of change because you have different numbers, but you can divide both of these by 3. So that means it does actually simplify to 15 because 45 over 3 does simplify to 15 or 15 over 1, however you want to think about it. And finally, my rate of change from day 3 to day 4, we've got 30 in the numerator. Let me put the right color in there. 30 in the numerator, and we're going to divide that by 2 in the denominator, which means this also simplifies to 15. So after comparing each individual change in our output to our change in our input, they all simplify to 15, which means that this does in fact represent a constant rate of change because each of them simplified to the same value. Okay, in example number 2, the same way that when you see a table written horizontally, you can always count on the fact that X will be in the top of the table and Y will be in the bottom of the table. When it's a vertical table, X is always going to be on the left and Y is always going to be on the right. So in this case, our input is going to be our time and our output or our dependent variable is going to be our height. So typically when I do a rate of change on a vertical table, I do it a little bit differently. I kind of make these little arrows out to the side to look at the change. So I'm going to go through and find my change in my X values. So that's increasing by 0.5, which means it's going to be a positive rate of change. And then from 0 to 18 is an increase of 18. So my rate of change is 18 over 0.5. And yes, you can have a decimal in a rate, but just in case it's really bothering you, what you could do is you could multiply the numerator and the denominator by 2 because a half times a half will give you 1. Just make sure that you multiply both the numerator and the denominator so that you get 36 over 1. You get the unit rate. In my second set of changes, you can see that it's going to be 13 over 1, which is already simplified and definitely not the same as 36 over 1, right? So we can tell because we don't have a constant rate of change because those two rates of change are different. So this, friends, will be a variable rate of change. And again, that is because once we compared our change in our Y values to our change in our X values, they were not the same.